So for question number 26, we have what is the slope of the line tangent to the polar curve r equals 1 plus 2 sine theta at theta equals 0? Now, I think this is a really good, I guess, exercise for a problem because you'll have to review polar coordinates again. So remember that in order to go from Cartesian, like xy coordinates, to polar coordinates, you're going to have to use the conversion x equals r cosine theta, and then y equals r sine theta. And the other thing you need to remember is that technically speaking, r is a function of theta, right? They give us our value of r, and it is a function of theta. So really what we have here is x of theta equals r of theta multiplied by cosine theta. And then we have y, or sorry, I should say y of theta. Y of theta equals r theta multiplied by sine theta. Now, this is essentially a parametric curve. It should look familiar. I don't know if you'll remember, but like, anytime you have like x of t or y of t, and we want to figure out the slope of the tangent line, we're going to use the formula dy dx equals dy dt over dx dt, etc. So in this case, what we're going to do is we're basically just going to do the exact same thing, but it's going to be with respect to theta. So we're going to have that dy d theta divided by dx d theta equals our slope of tangent line. Okay, so all I need to do now is just take the derivative of both of these functions here. So I will take the derivative of, let's see, so of x first. So I'll do d theta, x of theta, and then I'll take that derivative operator to both sides, and then I'll have r theta cosine theta. And when I do that, I'll have to use the chain rule and the product rule here. So I will get r prime of theta multiplied by d theta over d theta, which is just 1, obviously, and then multiplied by cosine theta plus, or I said, well, I'm just going to say minus because it's plus negative sine of theta, r of theta, and yep, that's it. Okay, so let me go on ahead and let's see, I'm going to clear some space here. So this is going to be our denominator. So let me go ahead and write it out here. It's going to be, I'm just going to write it as, well, yeah, I'll write it as dr d theta, where r is a function of theta. And then I'll multiply it by cosine theta, and then subtract away r theta. Let's see here, minus, well, sorry, multiplied by sine theta. Okay, so now that I have that, I will go ahead and erase all of this bottom one so that we can do the exact same thing for y. So let's see here. I'll do the same thing, and I'm just going to apply the derivative operator to both sides. I'm not actually going to write it out. That way I save room. So I will have that dy of theta over d theta equals essentially kind of the same thing, right? R of theta times d theta, which again just goes to 1, multiplied by sine of theta. Let's see, plus r theta cosine theta. So if I write that up here, I have dr theta over d theta multiplied by sine of theta plus r of theta times cosine of theta, lots of thetas. Okay, so now that I have that, I can go on ahead and plug in my values here. So let's see. Well, normally you would calculate, well here, I'm just going to plug in, well, how do I want to do this? trying to see if anything nice would happen. All right, I'm not going to calculate dr d theta. Sorry, yeah, dr d theta yet, but you will have to do it eventually. Let me just go ahead and plug in 0. So I will have, let's see. So remember that cosine of 0 is just 0. Wait, no, I'm sorry. I'm sorry, cosine of 0 is 1. Sine of 0 is 0. So this whole thing's going to go to 0. Let's see, is there anything else? And this whole thing is going to go to 0 as well. So I will have, and I'm just going to simplify. I'm just going to simplify this down. Let's see. So I will have r theta. Well, here I'm just going to write it like this. R evaluated at 0 times 1. And again, this entire thing, right, this all goes to 0 because we have that sine of 0, right? And then on the bottom here, I'm going to have r prime of 0 times 1. Yeah, that's it, because this bottom part with the sine also goes to 0. All right, so essentially I need my radius. So, okay. So again, I'm going to have 1 plus 2 sine of 0. I'm just plugging in 0 for this theta right here. And then r prime, let's see. So actually, I can erase this part and just do the 1 right there. And then now I'm going to go ahead and take the derivative of r with respect to theta. So I will do d theta r theta d theta 1 plus 2 sine of theta. And whenever I do that, I get dr theta d theta equals 2 cosine theta. So I will then have 2 cosine theta. All right. So theta is 0. So I will need to substitute in a 0 for the cosine. So I'll have 2 cosine of 0. I know that that's just going to be 1. So I will have 1 divided by 2 times 1, which is in fact 1/2. So that's a lot of work for one problem. A lot of times, I think most of your high school teachers will probably tell you to just like memorize that formula. But that's how you arrive at that formula. So, a little bit longer derivation, a little bit longer video, but hopefully you found it helpful. But yeah, the correct answer is going to be answer choice B, which is 1/2. So hopefully that helped. If you have any questions, feel free to comment below. I know I went through, a couple things pretty quick, but yeah, let me know if you have any questions, and I will see you guys in the next video.